Hello everyone, and thank you for being here. I'll be walking you through my C# console application called Xenobot, a cybersecurity awareness assistant. This project is designed to simulate a helpful chatbot that educates users on digital safety practices. I'll guide you through the code step by step, focusing on the logic behind each part. As the application begins, the bot greets the user by playing a .wav file. The sound is played using the sound player object, which is initialized with the file path of the desired .wav file. The soundplayer.play method is called to initiate playback of the greeting sound before the bot proceeds with its greeting. This is all within the main method of the program.cs class. The main method sets the foundation for the entire bot interaction. The header class file is dedicated to displaying ASCII art and setting the visual theme for the bot's introduction. The primary function of this file is the ASCII art method, which uses console.foreground color to change the text color in the console, ensuring that the displayed banner stands out. In this method, the color is set to magenta for the banner and a dark cyan for the secondary logo display. The console's color is reset after the art is printed using console.resetColor, which prevents the colors from affecting the next text. The Xenobot file contains the logic that drives the bot's interaction with the user. At the top, we have a static name property. This property is essential for storing the user's name, which is later used in personalized responses. The first method of this class handles the greeting and name input from the user. The method begins by outputting a welcome message using the typewrite method, which simulates typing text on the console for a more engaging interaction. The bot asks the user for their name and validates the input to ensure it is neither null nor white space. This is achieved through a while loop, which repeatedly prompts the user for their name until a valid input is provided. The loop uses a string is null or white space method to check the user's input. If the user enters a name, the loop breaks and the bot acknowledges the user by outputting a personalized confirmation message using string interpolation. Next, the XenoChat method facilitates the ongoing conversation between the user and the bot. This method also makes use of a while loop, which keeps the chat open until the user decides to exit by typing either X, exit, or quit in the console line. The user's input is captured using a console.readline, and the input is normalized to a lowercase and trimmed off excess white space through the toLower method and trim method. The normalization ensures that the program can handle variations in the user's input, such as uppercase or extra spaces, making the interaction smoother. If the user enters an empty string, the program detects this via the string is null or white space method and prompts the user to provide a valid input. This error handling mechanism ensures the program doesn't proceed with invalid inputs, enhancing usability. A key feature of the XenoChat method is the dictionary-based response mechanism. The bot uses a dictionary called responses to map user inputs to predefined responses. The dictionary stores keyword response pairs where the keys represent the cybersecurity topics such as phishing, malware, passwords, and safe web browsing, and the values are the corresponding responses that the bot will provide when a keyword is detected in the user's input. The program iterates through a dictionary using a for each loop, checking whether the user's input contains any of the predefined keywords. If a match is found, the bot immediately outputs the corresponding response. The use of break ensures that once a response is found, no further checks are made, improving efficiency. If no match is found, the bot responds with a default message suggesting other topics the user may wish to inquire about. Lastly, the type right method is used to simulate a typing effect which enhances the user's experience by making the interaction feel more natural. Instead of printing all the text at once, the method loops through each character of the message and outputs it with a slight delay between each character. The delay is controlled by thread sleep method, which determines the speed at which each character is displayed. This provides a more engaging and less mechanical feel to the interaction between the user and the chatbot. I will now run my application and show you how the chatbot works.
Hello, I am Zeno, your cybersecurity awareness assistant. My purpose is to provide helpful information and guidance to ensure your digital safety and well-being. Before we begin, could you please provide your name?
That was the chatbot's greeting. If the user does not enter a name and clicks enter, an error message will appear stating that the user has to enter a name. When the user enters the name, a personalized message will appear from the chatbot. Chatbot then asks the user to ask them a question about cybersecurity, or either to exit the conversation by typing X, exit, or quit. User can ask the chatbot how is it feeling, what is its purpose, and ask about what topics will it speak about. I will now show you that the chatbot is capable of answering basic questions regarding the following topics such as malware, phishing, safe browsing across the internet, and password safety. Before we do that, if the user does not enter anything into the console line, an error message will appear stating that the chatbot could not read the user's input and it should ask a question regarding the previous topics. If the user misspells a word in their sentence, the chatbot will then pop an error message stating that they could not understand the user's input. When we are done using the chatbot, we simply can type X, exit or quit into the console line, and it will close the application with showing a closing message.